Hi everyone, this is Kshitij, and on this channel we talk about robotics, research, and academia. So this is the third lecture of the TT102 lecture series where we are learning Python in an introductory level for robotics. In today's lesson, we are setting up a coding environment using Docker. So if you have worked with virtual machines, you would know that a virtual machine basically builds operating systems virtual copy on top of your host operating system. So if you have multiple virtual machines or a GUI heavy virtual machine, graphics heavy virtual machine running on your host OS, it starts to slow down. So Docker is an open application development environment which basically allows you to develop, run, and ship your applications to any member of your team anywhere around the globe. So you can have version control, you can have exact replicas of your system. So the other member does not need to sit and figure out why it works on one system but it doesn't work on the other. It will work as is. So you have basically two things in a Docker environment that help you execute something like this. So one is a Docker image and one is a Docker container. So a Docker image is a template or a blueprint that contains the instruction for creating a Docker container, and a container is a running instance of your Docker image. So if I send you an image, you will create your own Docker container at your own end, but that image is essentially a copy of my hard disk to some extent. It's not an actual copy like an ISO file, but more like a checkpoint. So whatever dependencies, whatever libraries, software tools, anything that I have had to install to make it run on my PC, you will already have them set up and ready to go for your PC. So if I'm running Ubuntu 20, you're running Ubuntu 16, you don't have to worry about upgrading your system and then making it work. You can have a Docker container there. Within that container, you'll do everything on top of your host OS. So you don't have to fidget around with whatever is your host operating system. So as you're going to see very soon, I'm going to make everything work on a Windows PC, even though ROS and most robotics applications require Linux. So we're going to build Linux OS on top of a host Windows OS inside a container. And to do that, we're going to use some of the standardized images. So what you're seeing in front is called a Docker Hub. So it's a registry or a repository of all the Docker images that people have put up on the web. So the first one that you're seeing, the OSRF ROS 2. So that's the sort of official open source robotics foundation developed ROS 2 image that you can use, and there's also a ROS 1 image, so you can have multiple images in your Docker environment, and then you can launch them inside different containers. So at any given point in time, you could be working with ROS 1, ROS 2, Python, C++, mix and match. You can also pass things around, but we're going to keep everything contained within a container. So in order to do that, the first thing that we need is an IDE, the development environment, for which we are using Microsoft Visual Studio Code. I'm assuming you have that installed already. If not, you can look it up on the web, Visual Studio Code, and install it at your end. Another thing that we're going to need is a Docker installation on your host operating system. So for example, as I said, I'm using Windows. So I have this blog on my website where I talked about the 10-step guide to getting started with ROS. And in there, you're going to find step 7, which is setting up ROS on your PC using Docker. So if you go down here, I also explain why we are using Docker in ROS. And there's a step-by-step installation guide. So when you click on this, you're going to land up on something like this. So this is a step-by-step workflow to install Docker and ROS on a Windows PC. So as you can see, it says go to Google and install Docker desktop if you haven't already. Once you do that, you're going to find Docker. So as I said, I'm doing it for Windows. Once you do that, it's going to start installing. Then you also need something called an X launch, which is necessary if you have graphical GUI-based applications, such as you're going to launch some simulators like Arviz and Gazebo inside ROS. So when you search that, you're going to find one by Xming and one by VCXSRV. I've used both of them at different times, so both of them are fine. Then you download that, you install that. Once it's ready, then you open a terminal and then you type Docker. If it gives you these kind of options, that means Docker is installed successfully. And then you can hit Windows and launch Docker desktop to see if it works. Sometimes you might have access issues as well. So you basically need to add yourself to a Docker user group using this command that I found on SourceForge. I've only had this on 1 or 2 of my PCs, but at other times, especially like the one that I'm using now, it worked out of the box. So sometimes you might have this problem. It might also ask you to update the WSL kernel. So if that's the case, there would be a button down below. So just follow the instructions and you'll be good to go. And then WSL basically is Windows subsystem for Linux. So you can open any Linux and stuff on your Windows PC. So you just type this command WSL -- update, and then that should be good to go. Now, when you launch Docker Desktop, it will start running. And then here is where you see your containers, the images that you have, any dev environment and extensions. So then you can look for OSRF ROS images like I showed you on the Docker Hub and install them. And then that's basically good if you want to use a terminal. But today we're going to deviate from this point onwards, and we're going to do this inside our IDE using Visual Studio. So this is our Visual Studio, and in order to be able to build and develop the code inside here, you're going to use a few different things. So number one is extensions. So you're going to need a remote development extension from Microsoft that includes a WSL, dev containers, a remote SSH, remote tunnels, like few different kind of extension packs. So it's a pack of 4. That is good to have. Then you're going to need, let's see, what else? You're going to need a Docker extension. So this is officially by Microsoft. So you're going to install that one. And then depending on whether you're going with C++ or Python, so you're going to need some language packs as well. So install those, right? So once that is up and running, we are ready to get started with our generating our Docker, pulling our Docker image from the Docker Hub, and then generating the first Docker container and starting to build environment where we're going to start coding from next time onwards. So what you're seeing here is pretty much an empty repository. Well, it's a directory. So I call it example workspace because in the ROS jargon, a workspace is where you store all your code, and SRC, the source folder, is where all your source code is going to live. This has nothing to do with Docker or ROS just yet, but we're going to get started now. So the first thing that we have to do is go down to this arrow where it says open a remote window at the very bottom. So this one. And then you're going to see some options. So you're going to look for something that says reopen in a container. So then it's going to open a remote window for us. And then it's going to ask about the configuration, whether you want to add a configuration to the workspace or the user data folder. So I'm going to use this. I can use source control. And then I'm going to look for ROS. So I've tried using different of these templates, ROS2 workspace and this and that, but the one that I found to work right out of the bat is this ROS by Ijnek. It's a very well laid out template that works very smoothly. So when you click on this, it's going to give you some ROS distro options to pick from. So I've tried using the Humble from here, but I've had some issues launching the simulators there, but I've tried using Foxy and that worked very nicely. So you click on Foxy, and then you can choose desktop or desktop full. I go with desktop, and then it gives you a whole bunch of options that you don't necessarily need to select, and then just click OK from here. So I'm showing you another of my workspace. So this is a slightly, let me move myself out of the way so you can see stuff. There you go. So this is a slightly different workspace. I haven't started coding anything in here yet, but just so you know. So once that process is completed, you're going to find 2 files that it generates inside the .dev container folder. So you're going to see a JSON file, which is devcontainer.json, which is here, and you're going to see a Docker file. What's important to be done here is you're going to find some extra stuff after run arguments. Just remove all of those because they create issues when you're running your GUI based applications. And another thing that I found which is important to add with your basically edit in this folder is through this channel called Articulated Robotics that basically allows you to launch GUIs directly from here. So there's this piece of code that needs to be added. I'm going to put this in the description below so you can copy paste, but it's Actually, a desktop light is a feature that allows you to launch virtual kind of window displays, right? So without that, your RVs and gazebo GUIs would not work. And what additionally I'm doing, so you can come down to ports here and you can add port here, or you could do that directly from here as well, where I'm doing port forwarding. So I use 2 ports and I give them labels. And once you build your container, you're going to start seeing them here with the respective names. And inside the Docker file, I haven't changed anything per se. This is the ready to use Docker file that you're going to get as is. And other than that, you can even change the name here, but I like to keep it so I remember my ROS distro. So once all of this is done, you've built your Docker container, which takes a while the first time. You can come here and do LSB release A, so you're running Ubuntu 20, and then you can do echo ROS distro, so you know that you're running ROS Foxy. Then what I did, I cleared everything. So we're going to do ROS2 package create, and then whatever is the name of your package that you want to create. So I use this spawn object package here. So if you do spawn underscore object, you can just leave it as it is. It's going to create a CPP package. If you don't want a CPP, you can add some extra parameters. You can also have dependencies listed here, but if you just press enter, so for example, I create another one, then you can see I meant CMake. Basically, it's a C++ package. It did not have dependencies yet, but you can always go inside your package, and inside your package.xml, you can edit and add your dependencies manually. Well, it created the package outside the SRC folder, but that's for testing anyway. But before you do that, you should cd to your source folder, and inside that you should have all your ROS packages. And once you're done adding your packages, make sure to do a call con build, so then it adds your build, install, and log folders. And then once that is done, then you have to do source install setup.bash file, and then you can start coding your whatever inside the SRC. You can start making your CPP files, Python files, whatever packages you want to do. So now we have our coding environment set up in this lecture. So from the next lecture onward, we're going to start building a code. And the first thing I want to do is to spawn a robot inside a simulation, and then spawn an object inside the simulation. So that would be the next lecture. So I hope you enjoyed today's lecture and you're able to set up the environment as well, so that from the next time we start coding stuff, getting our hands dirty with programming. And this would also, basically this is a complementary lecture to what we saw on implementing ROS. So that was for people who have some sort of understanding of how Docker works, and this is more for beginners who also want to build through an IDE. So once you have this VS Code, this extension, and this kind of procedure set up, you would not need to go through an external terminal. As you saw, I was using the integrated terminal. There's integrated ports, there's a debug console. So that's the beauty of using an IDE. With that said, be sure to like, share, and subscribe, and I'll see you again in another lecture of the TT102 lecture series.